Okay, so what we want to do here is we have a degree that is larger in the numerator than in the denominator. So this is going to go to a non-horizontal asymptote. Because the degree in the numerator is 1 higher than the degree in the denominator, it's going to go towards a slant asymptote or oblique asymptote. So to find this, we need to do this division. I'm going to show you the algorithm for doing this. I'll go through it fairly slowly, and then you can watch this video again when you try it for yourself. So we need to take 2x squared. Now, there's a missing term or two in this, and I find it useful for me just to add them back in. So I'm going to put a 0x in there, and then like this. So I'm going to do a division of these two numbers. I'm going to divide this by x plus 4, like this. So the algorithm is quite straightforward. I asked myself a few questions. In order to make x equal to 2x squared, what must I multiply x by? 2x. So I must multiply x by 2x, and I'll line it up with the other x's here, in order to get 2x squared. So let me do that. 2x times x gives 2x squared. Now I've got another term here. So I must also multiply 2x by that term. So 2x by 4 is going to give me how many x? So it's going to give me 8x. Now, as a last step, what we do is we do a subtraction of these two. So the reason I chose 2x in the numerator is when I do this subtraction, this one cancels this one. And we're left with 0 minus 8x. What will 0 minus 8x give? It'll give negative 8x. So lastly, I drop down the term in the next column. I drop down the minus 4 like this. Then I repeat. So this is one of these type of algorithms that just keeps repeating and repeating this process. So the first question I ask myself is what? Yeah, what must I multiply x by to get minus 8x? So I must multiply by negative 8. So negative 8 times x gives minus 8x. Negative 8 times 4 gives how much? Negative 32. And then I do the subtraction. Now here with this subtraction, obviously we've chosen these numbers because minus 8x minus minus becomes minus 8x plus 8x, and these cancel. But take care with your negatives. So we've got minus 4 minus minus 32. So that's minus 4 plus 32. What will that give us? 28. In terms of finding the slant asymptote, we don't need this remainder. The slant asymptote we have found already. It's here. So whatever you get here in the top part of your division will be your asymptote, whether it's a linear one like this, or a parabolic one, or of a higher order. So the asymptote is a slant or oblique asymptote. And it is y equals 2x minus 8. This is our answer. John.
Can you also find 2x squared plus 0x minus 4 by 2x minus 8?
Not quite following what your question was.
Are you multiplying them?
So what I'm basically doing is I'm rearranging g of x. So g of x, this allows me to express g of x in different forms. It's an algebraic manipulation. So g of x is equal to this. The result that I've produced here says that it can be rearranged algebraically to be x plus 4 times 2x minus 8 minus 28 over x plus 4. Sorry?
No.
You can use, if you did synthetic division last year for this, it's quicker and easier. You can only do, it's only good for dividing linear factors. So in this case, it's a technique which will be perfectly fine for this course, and it will work really well. My technique that we're doing here will work for harder, higher level courses. Yeah, let's have a sketch of this. What's the best way for me to sketch it? Okay, so what was our function? 2x squared minus 4, x plus 4. 2x squared minus 4, x plus 4. Two x squared plus 4 divided by x minus 4. Was it the other way around? So the function looks like this. The function looks like this. The asymptote we found was y equals 2x, what was the plus 8? Minus 8 or plus? Minus 8. And what we see there is it will approach this slant asymptote in this direction, getting closer and closer and closer as we go all the way up in both directions. And this is how the function will look. Okay? Yeah. All right. That's it for today. Have a go at the homework.